That concludes our updates for this first exciting quarter. And of course, the quarterly video would not be complete without the much anticipated and skillful wizardry of one and only John Rolfe.
When you think about it, what can actually be more sustainable than perpetual motion? We have here a perpetual motion machine. And there's lots of engineers in the audience, so you probably immediately see how this is going to work. It's based pretty much on Newton's second law. We're actually increasing R for radius, and that's how we're generating our power. Of course, that's really only true for speeds significantly less than the speed of light. But it's pretty impractical to turn this at that speed anyway, and then of course you might not be able to see it if it was turning at the speed of light anyhow. Or maybe you can. Maybe you see the back of it. I can never get that straight. Anyway, now the ones, of course, that'll be used to power cities later on will be a lot larger. They'll be made of more sophisticated materials. It just so happens that the entire quality department is with me here today for a meeting, so I brought them in to monitor and take measurements for our experiment, which is all about the hydrogen economy that you've heard so much about. The hydrogen will pass through this proton exchange membrane fuel cell. For this quarter's award, I've got this electronic dice module here, which can select a number from 1 to 12. And yes, it is possible for a 2-dice module, in this case, to select a number 1, because the designer thought that it'd be good for 1 to read 0. Were that a physical die, it'd be exceedingly unlikely, and I think somewhat disconcerting, but for electronics it'll work out well enough. Now all I have to do, as I said, is push a button and I'll get a number here on this display, but you're probably asking yourself the same question I did, and that is, why would anybody push a button when they could have a robot do it for them? Today's device is based on the actuator from an automotive windshield wiper mechanism, and in addition to being a random number generator, is actually an analog of INS operations. We'll push the tie rod, squeezing the vise, and smashing this unit here, which signifies the operations VP, and this compressing vise signifies David. As we squeeze the operations VP, the gear mechanism moves the ratchet and the dice will fall to direct this robot to drop the polycarbonate resin sphere onto this inclined plane. Now, as you all know, it's the 50th anniversary of the laser, and I'm sure you're all celebrating in your own way. I thought I would use laser as our tool this time for the random number. Laser, of course, was theorized in 1917 by Einstein, but it wasn't until 58, 59 when they did the first microwave frequency experiments and generated a maser that shortly after that the optical laser was developed. And I wanted to make the same type of optically pumped ruby laser, but Harold got a little testy about a large flawless ruby that I needed to do it. I'm thinking, well, I don't really want to outsource that. I think we should make a device that prints logos on mugs. So I've set one up here. Unfortunately, there's been a few really kind of minor engineering issues. I've had one of the first issues I looked at is that there was actually with a clearance of just 12 thousandths of an inch for the print head and the cup being about 4 inches in diameter. I've run quite a few computer simulations, and it's actually just not going to work to feed the mug into the slot on the printer. Okay, we've got Mr. Halgrimson in a much more receptive mode here. I think we're ready to test the mechanism. People have asked me in the past, why don't I just simply use a computer to pick the random number instead of various machines. I thought that was probably a pretty good idea, so I've actually constructed a computer and I've made a 4-bit unit here. Of course, the basic component being a flip-flop attaches to the second order bit with an inverter lever. So we'll go ahead and just take a couple more clock cycles. I've actually realized that my calculator has a random number function. All I actually have to do to pick among the top 10 is just push this one button and it'll get a random number. So in order to do that, I've devised this mechanism here